Smartwatches are becoming increasingly popular, yet their limited form factor makes input a challenge. Gaze, smooth pursuit, and blink have been proposed as an interaction modality to increase input vocabularies. However, eye-based input can suffer from the problem of false activations. We propose Blink Sync, a unique multimodal gesture that leverages synchronous touch and blink to augment the input expressivity of smartwatches. With Blink Sync, we introduce the concept of mutual delimiters, where the synchronous events of two different modalities are used to delimit the intention of each other's input. To inform the design of Blink Sync, we first conducted a lab study collecting data on touch and blink patterns during smartwatch use. Results showed that users rarely perform a synchronous pair of touch and blink events. We designed 5 Blink Sync gestures consisting of a blink synchronized with either a tap or a swipe in 4 directions. In an evaluation, we compared Blink Sync with other 2 techniques: touch after pressing the hardware button and normal touch. The results showed that a 250 millisecond threshold is big enough for users to consistently succeed on performing Blink Sync gestures, while being small enough to yield less than the 2% false activation rate. Furthermore, Blink Sync was significantly faster than pressing hardware buttons, while only introducing a small cost compared to normal touch. To illustrate potential applications of Blink Sync, we outline 2 potential use cases: one where blink augments touch input and one where touch augments blink input. We demonstrate how Blink Sync can be used to trigger system functions. Blink Sync left and Blink Sync right cycles between recently used applications. Blink Sync down terminates the current application. Blink Sync up shows all recently used apps. Note how users can still use normal touch to interact with the watch. Blink Sync can also be used to control IoT devices while addressing the false activations problem of eye-based input. To activate the device, users look at it and perform a Blink Sync up gesture. A Blink Sync tap gesture changes the light setting, in this case color. A Blink Sync down gesture deactivates the device. Blink Sync can also be used to extract UIs from devices for further control. For example, when a user looks at a speaker and performs a Blink Sync tap, a control UI pops up on the smartwatch for the user to control. Finally, when the user receives a notification containing a link, they can look at the desired display and perform a Blink Sync up, and the associated content will be opened on the screen, revealing the complete details of the message. We hope our technique will serve as important groundwork for future work on multimodal wearable input.